In this video, we're going to discuss how to construct a confidence interval for a mean when we don't know the population standard deviation. This process will feel very familiar as we're using the same steps that we did when we did know the population standard deviation. And the only replacement is now we're using the student t-distribution instead of the normal distribution. So that's going to change how we find our critical value. So when we're at the critical value step, we're going to be using inverse t instead of inverse norm to find that critical value. It's also going to change the formula for our confidence interval. The structure is still the same. It's the best point estimate for a mean, which is the sample mean, plus or minus our critical value, which is now a t-score, times the standard error. And we know the standard error should be a standard deviation for the population divided by the square root of the sample size. Since we don't know the population standard deviation, we're going to estimate it with the sample standard deviation. This does mean way back in step 2, where we were usually given the sample mean pre-calculated for us, sometimes they're going to give us a list here and expect us to calculate both that sample mean and standard deviation using 1var stats. Let's go ahead and do 2 examples so we can see what this process looks like in practice. So first example says, you do a study of hypnotherapy to determine how effective it is in increasing the number of hours of sleep subjects get each night. You measure hours of sleep for 12 subjects with the following results. Construct a 95% confidence interval for the mean number of hours slept for the population, assumed normal, from which you took the data. So I know that I'm constructing a confidence interval. That was in that last sentence, construct a 95% confidence interval. They've given me the confidence level. They've given me the definition of the variable, mean number of hours slept. And then they told me that I had 12 subjects, so they've given me a sample size. So we're going to work our way down that 5-step list. And my first is to define my variable. So I'm estimating the mean number of hours slept for the population. And then I'm going to summarize all of those values that I was either given or that I know I need. So I was given a sample size, which is 12. From that, I know that I'm going to need a degrees of freedom because I was not given a population standard deviation. I know I'm using student t. I was also given a confidence level. We know that it's 95% or 0.95. And then I'm going to use 1var stats to calculate x bar and s, our sample mean and standard deviation. So stat, enter, and we're going to put that data in a list. I know I did this correctly because if I go up to that last digit, I'm in the 12th spot. That's a good sign. And then to run 1var stats, I press second, or not second, but stats and calc. Data's in list 1, and we get a mean of 8.98. and a sample standard deviation of 1.29. So next step, I'm going to identify what it is that I'm doing. So I'm building a t interval for a population mean. It's a t interval, so I'm going to use the t distribution to find my critical value. So I'm drawing my picture. This is t instead of z on my axis, but 0 is still in the middle. And I know that I want 95% in the middle. On our calculator, we're going to go inverse t to find this. And since we haven't done this before, let's take a look at what that asks us for. So inverse t is asking us for an area and degrees of freedom. And you'll notice it doesn't give us that tail option. I have to give it the area to the left of the tail that I find. So what I need is this area here. And I know the whole curve is 100. If 95% is in the middle, that leaves me 5% for the tails. Half of that 5% is here, half of it is here. And half of 5 is 2.5, or 0.025. So area is 0.025 in that left tail. We know from earlier our degrees of freedom is 11. And when we run that, we get negative 2.201 if I round that. And I'm going to drop the sign because we don't care about the sign. So 2.201. You'll notice that t-scores are typically carried out to 3 decimal places, while z-scores are typically carried out to 2. I won't deduct points if you forget that on your test, but you will notice that pattern as you read statistical literature. From here, I just need to do the plug and chug in my equation and then write my sentence. So I know my confidence interval is sample mean plus or minus critical value times the standard error. And our sample mean was 8.98 hours plus or minus 2.201 times, and then 1.29 divided by the square root of 12. So let's do the minus calculation first. 8.98 minus 2.201 times 1.29 divided by the square root of 12. And we get 8.16. And then changing that subtraction to addition to get the upper limit, we get 9.80 rounded. So that tells us that we are 95% confident that the mean number of hours slept for the population is between those two values. Again, very familiar structure. We're checking those same boxes that we checked in our last video on confidence intervals. The only difference came in us using a different interval to construct it, or a different distribution to construct that interval, resulting in a larger than usual critical value and a wider than usual interval. Our sentence frame for summarizing our results is the same. The structure of the formula for the confidence interval is the same, just with the new critical value and using a sample standard deviation in substitution for the unknown population value. Let's try one more just to make sure that we have this concept down nice and solid. So our second example says that a random sample of 15 registered nurses in a large hospital showed that they worked an average of 44.2 hours per week. The standard deviation of the sample was 2.6 hours per week. Estimate the mean population with 95% confidence. So first set of directions, they tell me estimate, and they give me a confidence level. So that's telling me I'm making a confidence interval. They give me a sample size, random sample of 15. They say worked an average of 44.2 hours per week. And it says the standard deviation of the sample was 2.6 hours per week. So let's go ahead and formalize that. We're estimating the mean number of hours nurses work per week. And then I was given a whole bunch of information. Sample size is 15, so my degrees of freedom will be 14. And I know I need that degrees of freedom because they specifically said sample standard deviation, not population standard deviation. They also gave us a sample mean of 44.2 hours per week. And then they gave us a confidence level of 95%, which we know is 0.95 in decimal form. Because we were given that sample value for standard deviation, we know that we're using the t distribution. So this is a t interval for a mean. And I know that means that I need to use this student t distribution to find my critical value. The setup is going to feel like it did in our last example because again we're using 95% in the middle, which means 2.5% in each tail. The difference is going to come when I run that inverse t function call. Because remember that our inverse t function call asks for area, which is the same, but it also asks for degrees of freedom, and we have a different sample size than we had before. So that's going to give us a slightly different critical value here. Notice it is now a slightly larger value at 2.145. Next, we can go ahead and build our confidence interval. So sample mean plus or minus critical value times our standard error, S over square root of sample size. So 44.2 plus or minus 2.145 times 2.6 divided by the square root of 15. So our lower bound is 42.76. Then rerunning that calculation with addition, we get an upper bound of 45.64. So our sentence would be, we are 95% confident that the mean number of hours nurses in a large hospital work per week is between 42.76 hours per week and 45.64 hours per week. All right, if you have any questions on what you saw in this video, feel free to send me an email or drop by office hours. Otherwise, I'll see you in the next video.